Hi students, so myself once again Ishwar Rao. So my channel is KEMY-Chemistry. Today we have covered so many students asked me nature of oxides. So today we have to cover nature of oxides. So mainly oxides are three types. Oxides are three types. First one is free oxide or monoxide. Second one is peroxide, and the third one is superoxide. These are three categories of oxides. So free oxides means, so generally the oxides having M2O type of category. So ఏవైతే M2O అనే ఫార్ములాని సాటిస్ఫై చేస్తాయో దే ఆల్ ఆర్ అండర్ ఫ్రీ ఆక్సైడ్స్ అండ్ మోనోక్సైడ్స్. మోనో మీన్స్ వన్ ఆక్సిజన్, దట్స్ వై ఇట్ ఈస్ కాల్డ్ మోనోక్సైడ్స్. ఇన్ కేస్ ఆఫ్ పెరాక్సైడ్ ద జనరల్ ఫార్ములా ఈస్ M2O2. సో విచ్ అండర్ పెరాక్సైడ్స్. జనరల్లీ పెరాక్సీ మీన్స్ O bond O, ఎక్కడైతే O bond O అనేది ఉంటుందో దెన్ వీ కాల్ యాజ్ ఎ పెరాక్సైడ్. అండ్ ద superoxide general formula is MO2 type of oxides are called superoxides. So the main bit type of is generally in free oxides or monoxides the oxidation state of oxygen is an adutadu. So it is called oxidation state. Oxidation state. Then the of oxygen. So oxidation state of oxygen. In this case, oxygen oxidation state is -2. Is -2. How could you say minus? Generally, M2 means it is a monodental ion, either +1 group, 2 into 1 plus X is equal to 0. For example, I will tell you one thing. M2O. M means, for example, it belongs to first A group element, either sodium oxide is there. So N means sodium +1 into 2 molecules is equal to 0. Therefore 2 1s are 2 plus it is called X is equal to 0. 2 plus X is equal to 0. X is equal to -2. So that's why in this M2O type of oxide the oxygen gets -2 oxidation state. In case of M2O2 peroxy means O bond O linkage. The oxidation state of oxygen is generally -1. The oxidation state of oxygen is -1. In this case MO2 type of superoxides, the oxidation state is -1/2. The oxidation state is -1/2. What I told you, so the oxidation state of only the single oxygen only, but not two oxygens. I will tell you one thing, only the oxidation state of single oxygen only. In case of the two oxygens, in this case generally it is right O2 2 minus. In this case O2 minus. In this case O2 -1. సో ఇక్కడేమో ఆక్సిజన్ యొక్క ఆక్సిడేషన్ స్టేట్ రాశాను, ఒక్కొక్క ఆక్సిజన్ యొక్క ఆక్సిడేషన్ స్టేట్ లేదు ఇక్కడ రాశాను. ఇవేంటంటే జనరల్గా ఉన్న నెంబర్ ఆఫ్ ఆక్సిజన్ యొక్క స్టేట్ ఎలా ఉంటుందని రాశాను. ఇది ఎలా వచ్చింది? ఓకి క్రిస్ క్రాస్ పద్ధతి ప్రకారం 2 - వచ్చింది. ఇక్కడ ఎలా వచ్చింది? సో O2 కాబట్టి ఈ 2 - పైకి వెళ్తుంది, O2 2 - అనేది వచ్చింది. ఇక్కడ MO2లో O2 అనేది +1 కాబట్టి -1 అనేది పైకి వచ్చింది. ఇన్ ద సేమ్ సినారియో, so in case of the first A group elements, lithium and sodium exhibit M2O type of oxides. For example, Li2O lithium oxide and the sodium oxide. It belongs to alkali elements. It is a first A group elements. In case of the peroxides, generally sodium, only the sodium gives peroxides, M2O2 type. The examples are N2O2, Na2 and O2 kind of. In case of superoxide belongs to first A group elements, the remaining is potassium, rubidium and the cesium. These elements gives superoxides. The kind of oxides is MO2. M means potassium, KO2. M means rubidium, RbO2. M means cesium, CsO2. These are the reoxides, just like monoxides, peroxides and superoxides in case of the first A group elements only. It is the first A. In case of the second A group elements, there is no formation of superoxides. There is no formation of the superoxides. Only it gives only the monoxides and the peroxides only. So monoxides are generally beryllium, magnesium and the calcium gives only the monoxides, just like MO type. In this case, M2O2 type, the remaining elements are beryllium, magnesium, calcium. Barium and the strontium gives peroxides in case of the second A group elements. Very, very important concept it is reoxides, peroxides and superoxides. In this case of first A group elements, only lithium and the sodium gives monoxides. Sodium only gives peroxides. Potassium, rubidium, cesium gives, these all are the superoxides. In a second A group element, there is no form of the superoxides. It gives only the monoxides and the peroxides. Beryllium, magnesium, calcium gives monoxides. Barium, strontium gives peroxides. So the oxidation states also important. So in this case O2 minus, in this case O2 2 minus, in this case O2 minus 1. I will give another information. In case of O2 minus, it shows the diamagnetic nature. It shows the diamagnetic nature. In this case of O2 2 minus, it also shows the diamagnetic nature. It also shows diamagnetic nature. In case of superoxide O2 minus 1, it gives the paramagnetic nature. This magnetic nature is very, very important. How could you say the magnetic nature? Generally, this molecule is oxygen is 8 plus 2 electrons. It is a 10 electron system. It shows the dia. Generally, the simple tip is there. Every even number of electrons. Even number of electrons gives diamagnetic nature. So how could you say even? Oxygen atomic number 8 plus 2, 10 electrons. 10 is an even number, that's why it is dia. In this case, oxygen is 8 plus 8, 16 plus 2, 18 electron system is called diamagnetic nature because it is also a even number of electrons. But in this superoxides, oxygen 8 plus 8, 16 plus 1, 17 electron system. That's why it shows the paramagnetic nature, very, very, very important. So that is, we have covered oxides in case of the alkali elements, in the case of the alkali earth elements. So alkali earth elements do not give the superoxides, it gives only peroxides and the free oxides only. So it is called completely oxides. So thank you one and all, kindly watch.